Okay, so today we're going to start section 5. We're going to learn about the basic functions. You need to memorize the shapes that the basic functions are going to take on. So here is our first vocabulary word. It's defining the word continuity. And it's describing a function as being continuous over an interval of its domain. When you hand draw the graph, if you don't pick up your pencil, then the graph is continuous. As soon as you pick up your pencil and then start drawing another piece of the graph, that would be a discontinuous graph. So notice this one, the parabola shape here, when they went to graph it, they could draw this entire graph without ever lifting my stylus. However, here, notice if I were to draw this graph B, I could start it here, but then as soon as I get to this point, I'd have to lift up my pencil because it's got a break in the graph or a hole, and then to continue it, I would keep drawing. So whenever your graph, so let's say we have a graph here, if I can draw it all the way across the whole graph without lifting my pencil or my stylus, this is a continuous graph. If I were to graph it and maybe draw a piece, stop, make a point here, and then pick it up, and then keep going, then this would be a discontinuous graph. It's like there's a break in it. So it doesn't have continuity. And you're going to do a lot of this in calculus. All right, so here is the first basic function. This is the graph of the linear function. This is what we've been doing all along, graphing lines. Again, remember f of x is a fancy way of saying y equals. So this would be the graph of y equals x. Notice in the table here, they've plugged in different values of x. When you plug in -2 in this function, you would get a -2 out. When you plug in -1, you get 1. Again, you could do it using slope-intercept. Notice the y-intercept is 0, rise 1, run 1. The domain for all linear functions is going to be all real numbers. The range for all linear function is also going to be all real numbers. So again, we're going to memorize the shapes that these graphs take on. The next is the graph of the quadratic function. This is when you're going to have an x squared in your equation. So again, the graph of the quadratic function is going to take on a U shape. Now, if our x squared term is negative, then it would be an upside down U. And we're going to see this coming up in tomorrow's lesson. For today, what we want to do is memorize the shapes that they take on. If you ever forget, you can always plug in values of x and evaluate it. But what's going to be important is that you memorize the 3 points around the origin. So you're going to memorize what you get when you plug in 0, when you plug in 1, and when you plug in -1. For many of the functions, it's going to be the exact same order pairs. Notice the range on the quadratic function is not all real numbers, only the domain. The domain for this one, this U shape is going to get wider and wider and eventually cover the entire x-axis. So that's why the domain is all real numbers. However, remember for range, we go from bottom to top. So the first point we encounter as we go from bottom to top is the 0, and then it goes on forever to infinity. So that's why our range is restricted. It's only from 0 to infinity. The next function we're going to talk about is the cube function. So notice this one takes on a shape like this. Notice this is a faster graph. It's going up rather fast. When you plug in 2 and you cube 2, you get 8 out. Whereas when we plugged it into the x squared, when we plugged in 2, we got to 4. So this one goes up a little bit faster. The domain and range for this one is going to be all real numbers for both. Let me go back to the x squared. Again, the cube function, the domain and range are both all real numbers. Again, memorize the shape that the graph takes on. The next graph we're going to talk about is the square root function. This one is also going to be restricted to real numbers. So notice none of my x values here are negative. So all my x values are positive and 0. So that's where my graph is only located over here. And it takes on this shape. Notice this graph is going up a little bit slower. Again, when you square root 4, you get 2. When you square root 9, you get 3. So it's creeping up very slowly. And again, this one has a restricted domain and range. Again, it's only positive values. So from 0 to infinity for both the range and the domain. The next graph we're going to talk about is the cube root function. Sort of looks like the cube function turned on its side. So this takes on this type of shape. And again, you would look at the order pairs. When you plug in -1, you get -1. When you plug in 0, you get 0. And 1, and you get 1. Again, the domain and the range for the cube root function is going to be all real numbers. So for the cubes, we can find the cube root of a negative number. But for the square root, we can't. And then the last one is called the absolute value function. This one is going to take on a V shape. So notice the V. So this would distinguish it between the quadratic, which is a U shape, and this one would take on a V shape. This is 1 to 1. So when you plug in -2, you get +2 when you absolute value it. -1, +1, 0, 0, 1, 1, 2, 2. The domain is all real numbers. However, the range is restricted. So for this one, it goes from 0 to infinity. Next thing we're going to talk about are piecewise functions. And this is sort of looking like the graphs that we were looking at on the quiz when we had to find increasing, decreasing constant. So for a piecewise function, notice in this example, we've got two different functions happening here. We're going to use the first one when x is going to be less than or equal to 2. We're going to use the second function when x is greater than 2. So this is why it splits my graph into two different things on the left side where the numbers are 2 or less, and it'll be a different graph when they're greater than 2. So let's see this. These are both linear equations. So if you remember that f of x, again, is a fancy way of saying y equals. This one is really y equals -2x plus 5. And then this one could be y equals x plus 1. Now, I only use the red one when my values of x that I plug in are 2 or less than 2. So let's go ahead and plug them in, and let's see if we can create some order pairs. So if I use the red one first, and I take this equation, the first thing I'm always going to try to plug in is what is my restriction here. So it's 2. So I'm going to plug in a 2 for x. I'm going to evaluate this, -4 plus 5. So y equals 1 when you plug in 2. So that would be my first order pair I graph. Notice it has the less than or equal to symbol. So that would be a closed circle on the order pair 2, 1. Now, I want to get another point to create a line. Now, I could also use my slope, and from that point, I could go up 2 and to the right 1. But let's just plug in a value for x that's less than 2. So I could also plug in, say, 0, because that's less than 2. So -2 times 0 plus 5. -2 times 0 is 0, plus 5 is 5. So when I plugged in 0, I get 5. So then I could come over here, graph this point, and then I can connect them and make this piece of my piecewise. Now let's do the blue one. So again, my restrictions are values of x that are 2 or larger. But notice it's got just the greater than symbol. So I'm going to plug in 2. But when I graph the order pair, I'm going to use an open circle. So I'm going to take x plus 1. I'm going to plug in 2. 2 plus 1 is 3. So the order pair I'm going to graph is 2, 3. When I graph that, notice it's an open circle. Now to get another point on the line, I'm going to pick an x value that's greater than 2. So I could plug in 4 or 3, any number bigger. Let me plug in 4. So if x equals 4, I get 4 plus 1, and I get 5. So I would graph the order pair 4, 5. So I can come over here, put my point, connect them, and point it to infinity. That's how you can graph a piecewise function. You're going to pick x values that satisfy this. So any number that's 2 or less, you plug in here and get order pairs. Any number that's greater than 2, I would plug into this equation. And it creates your piecewise function. Let's try another one. Yes. All right, let's try the other graph that's over here on this side. So again, we have 2 separate ones. So when x is a value that's less than or equal to 1, we use this one. When x is greater than 1, I use this equation. So let's try the first one. So I would take 2x plus 3. I'm going to plug in 1 because notice it's got this or equal to, and this is the number where I got to start it at. So 2 times 1 plus 3. 2 times 1 plus 3, and that gives me 5. So this order pair would be 1, 5. And notice it's graphed here. So close circle. And now I'm going to pick another number that's less than 1. So I could plug in 0. So 2 times 0 plus 3. And then my order pair would be 0, 3, which is right here. And then I can connect and graph this piece of the piecewise. So that would be this. And now I'm going to do the other function, and I'm picking numbers that are bigger than 1. Now, notice when we plug in 1, notice there's not an open circle on this graph, because when I plug in 1 into this function, notice I got exactly the same answer, and it was already taken care of from the other function. So let me pick a number that's greater than 1 and plug it in. So if I plug in x equals 3, negative 3 plus 6, and I get 3. So I would graph the order pair 3, 3, and then put a point, and then graph it. So you're just graphing 2 different functions on the same coordinate plane, and you can either use the slope and move it that way, or you can plug in different values for x that satisfy this restriction here. Let's try now. I know on your slides, the rest of them are blank. So I want you to write these piecewise functions down, and we're going to get some order pairs. So here's another piecewise example. So it's f of x, and it's going to be equal to x minus 2 and 5 minus x. We're going to use the top one when x is less than 3, and we're going to use the bottom one when x is greater than or equal to 3. So let's go ahead and see if we can get some order pairs, and let's see if we can graph this one. So for this one, I'll do this one in blue. So I'm going to pick values. I'm going to start with 3, and I'll just put an open circle for that one. So x minus 2, I'm going to plug in 3, and I get 1. So this order pair would be 3, 1. I'm going to pick another number that's less than 3. So I can also plug in a number less than 3. I could plug in 0 and get negative 2. So 0, negative 2. So let's go ahead and let me graph this. So I'm going to graph 3, 1. Now this one, when I plugged in the 3, notice it's going to be an open circle. and then 0, comma, -2 is going to be down here. So that one's going to point in that direction. Now for the next one, I'll do this one in green. So I'm going to take my 5 minus x. I'm still going to plug in the +3. And I get 2. So 3, comma 2. Let me graph that one. Close circle because it has the or equal to. Then I'm going to pick another number that's greater than 3. I could pick 5. And I get 0. So I would graph 5, comma 0. So 4, 5. And then put a point here. And then point it in that direction. Okay, here's another piecewise. F of x again. And again, you could use any letter. This one's going to have 3. I'm going to do -2x, 3x minus 1, and -4x. So for the first one, that one's going to be when x is less than -3. For the middle one, it's going to be a range of possible x values. So it's going to be any x that's in between -3 and +2. And then for the last, all the values of x that are bigger than 2. So really what we're doing is we're dividing up our graph. Let me draw a coordinate plane here. 1, 2, 3. 1, 2, 3. All right, so for the first one, I'm going to plug in -3 because that's going to be like my starting point, and then it'll be everything that's less than that. So if I take -2x and I plug in -3, I get +6. So I'm going to go over to -2, and then I'm going to put a point on +6. And it's an open circle. Okay, then next, I'm going to plug in another number. Let's plug in another number that's less than that. And we could plug in, let's plug in -4. So -2 times -4 gives me +8. So over here, I'll come to -4, and then I'll go up to +8. So we can see the graph is going to go up in this direction for the first function, or the first piece of the function. Then the next one, this middle one, the x's I'm going to plug into the middle one could be, I'm going to do -3 for sure. And I get -9 minus 1. I get -10. So the order pair -3, -10. I could plug one in the middle. I could plug in 0. And get 0, comma, -1. And then I'm also going to plug in 2. So 3 times 2 minus 1, 6 minus 1 is 5. So 2, comma, 5. So let's go ahead and graph these 3 order pairs. I'm going to put it, here. And then here. So -3, -10 is going to be way down here. Then I'm going to graph 0, -1, and then I'm going to graph 2, 5 up here. So again, this stops. So this is for the range in the middle here. And then the last piece, I'm going to plug in 2. I get -8, so I'm going to graph the order pair 2, -8. Then let me just pick another number that's bigger than 2. I could plug in 3 and get -12. So 3, -12. So for this one, I'm going to graph 2, -8. So 2, 3, 4, 5, 6, 7, 8. So 2, -8 could be right here. And this is an open circle. And then 3, -12, it's going to be down here. So this would be this piecewise function. Let's do one with an absolute value piecewise. Let's do another one. Okay, so this one I'll call g of x. Again, I could call it f of x again, but just realize that you can use any letter you want. I'm only going to do 2 this time. So I'm going to do absolute value though. Absolute value of x minus 4. And I'm going to use this one when x is less than or equal to 1, negative 1. And then I'm going to use negative x squared when x is less than negative 1. So let's try this one. See what kind of order pairs we get. Okay, let's wait. We'll do this one tomorrow. So let's just go back over the parents and make sure we're on everything on the parent functions. So again, recall that when it's a linear function, if you forget the order pairs, make your own little chart. So plug in whatever x values you want. You need to really memorize plugging in a -1, a 0, and a 1. So for the linear, it's easy. Whatever you plug in comes out the same. And again, you would graph. Make sure that you understand that the graph of the linear function is a straight line. This would be the parent, and then we're going to shift it starting tomorrow. Remember, the domain and the range for the linear function is all real numbers. Next one is the quadratic, y equals x squared. Remember, this is going to take on a U shape. Again, you could do a chart. At least get these 3 points on there. So when you plug in -1, you get +1. When you plug in 0, you get 0. When you plug in 1, you get 1. So again, it takes on this shape, and you make it a U shape. You can also plug in 2 if you want, or 3 to get more points. This is the shape of the quadratic function. The domain is all real numbers. The range is going to depend on where that vertex is. The range here would be from 0 to infinity, but domain is all real numbers. Next one was the x cubed function. Again, remember that one took on it's on this shape. So again, you can do your chart, plug in -1, out comes a -1, plug in a 0 comes out. Plug in a 1, 1 cubed is 1. So this order pair, this one, and this one. If you want to see how fast it goes up, you could plug in 2 and -2. Here would give you 8, here would give you -8. This is the graph of the x cubed. Again, you're going to memorize that the domain and the range are all real numbers. The next one that you need to know is, let's do the square root. And these were all the ones that had the screenshots. But I'm just trying to show you that you can figure out the order pairs yourself. So you plug in a 1, the square root of 1 is 1. Put in a 0, is 0. Okay, remember that we don't want any imaginary numbers, so we're only going to plug in positive values for x. The next perfect square after 1, if I square root something, would be 4, and you get 2. So to get this one, since we don't have -1, 0, 0, 1, 1, and then you'd come over here to 4. So the graph of the square root function looks like this. The domain again for this is positive numbers, so from 0 to infinity, and the same for the range, 0 to infinity. The other one was the x cubed. That looks like a sideways cube function. So if you have x in the cube root, again, it takes on this shape. Again, you could do your little chart. -1, the cubed root of -1 is -1. Cubed root of 0 is 0. Cubed root of 1 is 1. So this order pair here and here. And again, the last one, the absolute value function, memorize it takes on the V shape. going to be like this. Again, absolute value. You could plug in and do your chart. When you plug in -1, you get +1. When you plug in 0, you get 0. And 1, you get 1. So memorize that the absolute value takes on the V shape. So I'll do that last piecewise function tomorrow. Tomorrow we're also going to practice shifting these graphs up and down and left and right. We're also going to shrink and stretch them.